we are asked to find the range of the rainfall data. So it's important to know the definition of this term. The range is the maximum value minus the minimum value. So to find the range of the rainfall data, we should identify the maximum and the minimum and then take these values away. Scanning through the rainfall data, the largest number we see is 155. So this is our maximum rainfall. The smallest number we see is 47. So the minimum rainfall is 47. To find our range, we subtract the minimum from the maximum. So we get 155 minus 47, which is 108. The unit for our rainfall was millimeters, so that's the unit we'll want to use here. In part 2, we need to find the year with the highest June rainfall. Well, we've already looked at our rainfall data and found the highest value. It was 155. This occurred in 2003. So the year with the highest June rainfall is 2003. In part 3, we want the year with the least June sunshine. To solve this, we'll need to scan through our sunshine data and look for the smallest number we can find. Once we do this, we'll notice that the smallest number is 124. This occurred in 2002, so the year with the least June sunshine was 2002. There's several approaches we could take to argue which of these had the best weather. Most people don't like having rain in June. So one reasonable approach would be to say that the best weather was the year which had the least amount of rain. If we scan through our rainfall data, we'll notice that the smallest value is 47, and this occurred in 2006. So we could argue that 2006 had the best June weather since it had the smallest amount of rain. There's several other approaches you could have used here, and as long as you justified your answer with data from the table, you would have gotten the marks. In part C, our first task is to write the rainfall data in increasing order. In other words, from smallest to largest. Well, in part B, we observed that 47 was the smallest value in our rainfall data. So let's start with this. Scanning through our numbers, we'll notice that 72 is the next smallest value. It's worth pointing out that I'm circling my values as I go along here, since this makes it easier to keep track of the numbers we've already used. Looking at our remaining data, the next smallest value is 84. The next smallest value is 94, and this appears twice, so we'll want to include this twice on our list. Next on the list will be 101, then 133, then 134, 149, and finally 155. So this is our data listed in increasing order. We're not done because we're also asked to find the median of this data. So what does this word mean? Well, the median is the middle value when our numbers are listed in increasing order. And if there are two numbers in the middle, then we should add them and divide by 2. So, to find the median, we'll need to identify the middle number or numbers. A nice way to do this is to repeatedly cross off the smallest and largest number on the list. To begin, we'll cross off 47 and 155. Then we cross off 72 and 149. Next, we cross off 84 and 134. And then we cross off 94 and 133. We've now reached the middle, and there's two numbers which are equally central, 94 and 101. In this situation, the median is found by adding together the numbers and dividing by 2. So here, we'll get 94 plus 101 divided by 2. This gives us an answer of 97.5. The unit for our rainfall was millimetres, so that's the unit we'll want to use here. We're asked to find the mean number of sunshine hours. So how do we find this? Well, the mean is found by adding up all the values and then dividing by the number of values. We want to find the mean of the sunshine data. The first step will be to add up all these numbers. When we type this into our calculator, we get an answer of 1818. To find our mean, we should also count up the number of data values. Here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So the number of values is 10. To find our mean, we just have to divide these two numbers. It's 1818 divided by 10. This gives us an answer of 181.8 hours. In the next part, we need to identify which years had sunshine data within 5% of the mean. To do this, we should begin by calculating what 5% of the mean actually is. We found that the mean was 181.8, and when we multiply this by 5%, we get an answer of 9.09. So what we're after here is finding all the years which had sunshine data within a distance of 9.09 of the mean. We can concretely find our boundaries by subtracting and adding 9.09 from the mean. The lower boundary will be the mean, 181.8, minus 9.09. This gives us 172.71. The upper boundary will be the mean, 181.8, plus 9.09. This gives us 190.89. From here, all we have to do is scan through our sunshine data and identify the values which fall in between these two boundaries. 169 is not contained in between our boundaries. It's too small. 124 is also too small. 180 is between the boundaries. It's between 172.71 and 190.89. Similarly, 173 is contained within the boundaries. 239 is too big. 159 and 168 are both too small. And 228 and 205 are both too big. So the only numbers which fell between our boundaries was the 180, the 173, and the other 173. These correspond to the years 2003 2004 and 2005. So these are the years that the sunshine data fell within 5% of the mean. Modern calculators have built-in functionality to calculate the standard deviation. We'll want to avail of this to solve this question. Here's a brief guide of the steps to perform for the Casio FX83 GTX calculator. We begin by pressing the menu button. Then we'll press 2 to select statistics. Next, we'll press 1 to select the one variable option. From here, we need to type in our data. We want the standard deviation of the rainfall data, so these are the numbers we'll need to type in: 72, 133, 155, 101, and so on. After we've typed in our data, we'll press the OPTN button in the top left corner, and then we'll press 3 to select the one variable calc. When we do this, our calculator will display a number of statistics. The standard deviation has the symbol sigma x, and it can be found on line number 5. When we perform these steps, we'll get out an answer of 33.460,57381. We're asked to present our answer correct to one decimal place, so we should round this off to 33.5. Since the unit for the rainfall data was millimeters, that's the unit we should use for our answer. In our scatter plot, the horizontal axis is labelled with the total rainfall. The vertical axis is labelled with the total sunshine. Each point we plot will contain a pair of these values, a rainfall value and a sunshine value. The first 4 points have already been plotted for us. The first pair in our table had a rainfall value of 72 and a sunshine value of 169. This corresponds to the point right here. The next point had a rainfall of 133 and a sunshine of 124. This corresponds to this point. 155 and 180 corresponds to this point, and 101, 173 corresponds to this point. We'll need to plot the remaining pairs ourselves. First up, we'll have a rainfall value of 94 and a sunshine value of 173. To plot this, we'll go to 94 on the horizontal rainfall axis and 173 on the vertical sunshine axis, and plot a point right there. The next point has a rainfall value of 47 and a sunshine value of 239. So the point would be right here. The rest of our points can be plotted in a similar way. This question involves a correlation coefficient. There's 2 key facts we should keep in mind here. positive correlations have an upward trend, and negative correlations have a downward trend. Also, the larger the correlation, the stronger the trend. If we look at our points, we'll notice that they follow a downward trend. This means that the correlation will be negative. This rules out 0.6 and 0.1. A correlation coefficient of 0 means that there's no relationship or trend between our two quantities. Correlations which are close to 0, such as minus 0.1, means that there's almost no trend at all, and if there is one, it will be very difficult to notice. Since our data does contain a noticeable downward trend, we can rule out the minus 0.1. So our answer here is minus 0.6. Our justification here is that our data contains a noticeable downward trend.